Have you ever heard people throw around terms like unit testing, black box, or regression testing and kind of felt like you were just nodding along? Well, if you have, you are in exactly the right place. We're going to build a really simple mental map to show you how all these different types of software testing actually fit together. Okay, so let's start with a really foundational idea from the absolute legend, computer scientist Edsger Dijkstra. He said, testing can show the presence of bugs, but never their absence. Now, that's not just some clever line. It's really the core philosophy of all testing. The goal isn't to prove something is perfect, because you can't. The real goal is to lower the risk, to find the really critical issues, and just to build confidence that the software works the way it's supposed to. So if we accept that we're never going to find every single bug, how do we make sense of the dozens and dozens of ways people try? Honestly, it can feel like this just chaotic, random list of terms. So let's build a clear map together, a way to organize all these ideas so we can understand what they are and when to use them. We're going to look at testing through 5 different lenses. Now, the key thing to remember is that these aren't separate types you choose from. They're more like overlapping layers that describe any test you might do. We're just going to ask 5 simple questions. Is a human or a machine doing it? Are we reading the blueprints? Are we driving the car? Are we testing a single tiny screw or the whole machine? Can we see inside the engine? And finally, what exactly are we trying to prove with this test? All right, our first lens. This one answers the most basic question of all. Who or what is actually performing the test? Is it a person clicking around and exploring the system, or is it a machine just running a script? So on one side, you've got manual testing. This is where a person, a human being, is literally clicking through the app. And this is fantastic for exploratory testing, for finding those weird, unusual bugs that really require human intuition. On the other side, you've got automated testing. This is where scripts run a bunch of predefined checks over and over again. It's incredibly fast, it's super reliable, and it's perfect for those repetitive tasks you need to check every single time the code changes. Okay, so our second lens moves from who is doing the testing to how they're doing it. The question we're asking here is, are we checking the code itself, like an editor proofreading a book? Or are we actually running the finished software? First up, we have static testing. The best way to think about this is like checking an architect's blueprints before any construction starts. You aren't testing the house itself. You're just analyzing the raw materials, the code, the requirements, the design docs, without ever running the program. The whole idea is to catch design flaws really, really early, before they become super expensive to fix later on. And of course, its opposite is dynamic testing. This is all about testing in action. You're actually running the software, you're giving it inputs, you're clicking buttons, and you're checking to see if the outputs are what you expect. So if static testing is checking the blueprints, dynamic testing is turning the key in the ignition and taking the brand new car for a drive. Okay, let's move on to our third lens. This one answers the question, are we testing a single screw or are we testing the whole machine? This is all about scope, and we start with the smallest little pieces and we build our way up to the entire system. It's really a bottom-up process. We start at the tiniest level with unit testing, where a developer tests one little function completely on its own, just making sure the engine starts, right? Then we move up to integration testing, and that's where we check how those pieces work together. Does the engine connect to the transmission correctly? From there, we do system testing on the entire, fully assembled product, the whole car. And finally, you've got acceptance testing. That's basically the customer's test drive, confirming the car actually does what they need it to do. Our fourth lens is a classic, the box methods. This whole perspective is about how much visibility the tester has. Are they looking at the software from the outside, just like a user would, or can they actually see the code running on the inside? So on one end of the spectrum, you have white box testing. Here you're like a mechanic with the hood wide open. You have full access to the source code, you can see every single internal detail. Then on the complete opposite end, you have black box testing. Here you're just the driver. You have zero knowledge of the internals. You just use the controls and see what happens. And sitting right there in the middle is gray box testing, where you have some partial knowledge and you're really focused on how the major components interact with each other. And that brings us to our final lens, which answers our last question. What exactly are we trying to prove here? We're not asking how we test anymore, but what specific goal we actually have in mind. Now, this category is actually so broad that we can split it up into 3 distinct purposes. We're either testing what it does, its features, or we're testing how well it does it, its qualities, or we're testing what might have broken after a recent change. Let's take a quick look at each one. So functional testing is probably the most straightforward one. It answers a really simple question.
Does this feature do what it's supposed to do? When I click the save button, does the thing actually save? When I search for a word, do I get the right results? It's all about just verifying the requirements.
Non-functional testing, on the other hand, isn't about what the software does, it's about how well it does it. This is where we get into testing the qualities and the characteristics of the system.
And this category covers a huge range of different qualities. For example, performance testing asks, is it fast enough when 1,000 people are using it all at once? Usability testing asks, is this actually intuitive for a new user? Security testing is all about looking for ways to break in. And failover and recovery testing asks, hey, what happens if the server crashes? Can it get back up gracefully? Each one is a specialized check of the system's character, not just its features.
And finally, let's clear up 3 tests that get confused all the time because they all have to do with change. The main difference between them is scope. A smoke test is broad and quick. It just asks, is this new version stable enough to even bother testing? A sanity test is super narrow and specific. It asks, did that one tiny bug I just fixed actually get fixed? And then regression testing is broad and thorough, and it asks maybe the most important question of all. Did my recent changes accidentally break something else that used to work? So, after going through all 5 of those lenses, we get to the single most important takeaway here. These are not separate types of tests you choose between. They are overlapping layers. Let me give you an example. You could have one single test that is automated and also dynamic that tests at the integration level, uses a black box method, and is there to verify a functional requirement. See? All 5 lenses can apply at the same time, giving you a complete picture of what that one test is doing. So to make this all feel real, I want you to think about an app you use every single day. What's that one tiny thing about it that just drives you crazy? A confusing menu, a button that's impossible to find? Whatever it is, you've just found a failure of usability testing. And now you know that that's just one of the many, many ways we all try to make software just a little bit better for everyone.